Hi, all. I'm Rob Telson, Vice President of Ecosystem and Partnerships at BrainChip. Welcome and thank you for joining our latest episode of our BrainChip podcast series. These events are structured to provide current and future investors and those interested in AI and the BrainChip technology a path to better understand who we are, what we are doing, and where we are going. If you have not listened to any of our podcasts, please go to our website at www.brainchip.com, go to our media tab, where you will find our podcasts. You can also listen to any of these podcasts on your favorite podcast platform, or please go to our YouTube channel at BrainChip Inc. and find all of our podcasts and additional media. It's been a while since we've taken this approach. It's what I call an inside looking out approach. Traditionally, we do outside looking in, but on our podcast series. So today, we have the pleasure of having BrainChip's own Peter Vandermade, founder and chief technology officer, and Nandan Nayampally, chief marketing officer, on our podcast. Peter, Nandan, welcome to the BrainChip podcast.
Yeah, happy to be here. Thank you.
Yeah, thanks for having us on, Rob.
Yeah, I got to tell you, I'm very excited about today's podcast. The intention today is that this is going to be like a fireside chat, more of a roundtable, where we're really going to be able to get into the thought leadership. So being here with both Peter and Nandan means a lot of valuable insight into BrainChip, what we have accomplished, where we are going, and the future from their perspective on the world of AI. So I truly admire the work that Peter has put into driving BrainChip's architecture. His efforts and vision have been the cornerstone of BrainChip. And personally, thank you, Peter. And Nandan brings very broad industry experience with a deep product marketing background, decades of IP experience at ARM and other companies, and most importantly, a very strong AI background as well. So for our listeners, I've had the opportunity to work with both of these gentlemen and can truly attest we are in good hands. And these are the things that get me excited. So let's get started. Let's start with, I'm going to try to do this kind of as the host of this discussion here. And I'll start with Nandan. Let's focus on edge-based AI and what are the key drivers and some of the problems that you feel currently need to be addressed in today's AI market.
Yeah, thanks, Rob. So let me start with a common view, right? As cloud has grown and things like Internet of Things have grown along with it, the assumption always was that there is a dumb device at the corner, most of the intelligence and the computation is done at the cloud. It creates lots of challenges, and what you've seen over the last decade or so is that intelligent compute, power efficient compute, is moving closer to the end device, to the end user, and only the right amount of actual computation is getting done on the cloud. Now, AI follows a very similar process. The overall intelligence grows as all these local intelligences contribute to it. But unless you have local intelligence, you have a bit more stunted global intelligence, right? And let's talk about the commercial aspects of it. The cost of compute at the cloud is growing rapidly. The more the data gets thrown in and more complex things that need to be done or applications that need to be done, the bigger the bill at the back end. And especially things like storage, nearly 2/3 of the cost of cloud compute is in the storage aspect. So a natural side effect as a part of it is the network congestion. But more importantly, what you need to do at the edge in terms of how responsive is it? Is it fast enough to give you the experience? If I was in a zone that could not connect to cloud, would I be affected badly? If I was driving and I needed immediate reaction and it had to be done in the cloud, you couldn't do it. You see similar things in industrial, you see similar things on your home personal devices, right? So effectively, that is what is driving the need for edge AI. Now you add to it the fact that a lot of this data is now sensitive. You want more intelligence at your device, both to protect sensitive data, private data, but also reduce the amount of data that goes back and forth. So these are some of the key challenges that are driving the need for edge AI.
Thanks, Nandan. Appreciate it. Peter, what do you see as from your perspective, some of the key challenges as well that currently need to be addressed?
Yeah, as Nandan already mentioned, the traditional way of doing things is to go up to the cloud and do all the computing in the cloud. That presents certain problems. Now, one of the problems that are not so obvious is the enormous power consumption of the data centers around the world, where the total power consumption of those data centers is larger than the entire United Kingdom is using over a year. So we have a solution to this problem in Akita, in that we have a very low power consumption device with a thermal footprint that is extremely small. Moving devices to the edge of the closer to the application, you can save. We have calculated something like 97% of that power. So Akita will run off 3% of the power that currently is being consumed if we were to move all the applications to the edge. So that's a very strong driver, especially in the current climate, where we see climate change and all the problems with more violent weather that we need to address. So moving devices like Akita onto the cloud, onto the edge, from moving things away from the cloud, it means that we will impact that problem.
Yeah, just building off of what you said, Peter. For our listeners, and just let's take that and digest that. We've talked about before that we're at the forefront of this revolution. And what you've just heard Peter say is basically the means to an end, is that eventually the amount of compute that's going on in the world today, we can't sustain it. And it's going to take technologies and advanced architecture like what Peter and his team have started and done with Akita and what we're building on to support the compute as we continue to evolve. And so this is what you've just heard very clear, is that, hey, this is a big problem. It needs to be addressed, and it gets addressed by companies like BrainChip that develop products and then introduce new products and build upon the technology as we evolve. Before I move on, is there anything else that you guys want to add before I go to the next question?
Yeah, one of the important factors that that Akita offers high performance at a very low power consumption, and that's a key to people want high performance at the edge. That's a very important part of our value proposition, is that we can offer that performance, and yet at a very low power footprint, low thermal footprint, and
yeah, when we're thinking about thermal footprint and power, I think what you get there is that now you combine that. You combine the performance factor with the ability to really manage that power, and where we can take the technology expands dramatically. And what you'll see, I'm going to move on to the next question, because it really ties into what we just talked about, guys. And basically, let's look at what we have today. And what we have today is we've developed the IP that you can design into chips that enable you to build the AI engine into your device and support all of this compute moving forward. And we've done that based off of a product that we called Akita 1000. And so we offer that product as silicon, as development systems, and also in boards to enable companies to start building prototypes and move forward at a very fast pace as they continue to design out their AI strategy. But when we think about it, we've had shareholders and we've had people very interested in BrainChip ask the simple questions of, okay, well, if I was going to take Akita today, what are the perfect markets? What type of products would it go into that it fits in very well right now? So Peter, just building off of what we've talked about, if you were a customer of BrainChip, what would be to you the perfect customer that would be taking our technology today?
Well, there's a number of perfect customers. It's not just a perfect customer. I think
Exactly.
you see the application in consumer markets where you have products that you can speak to and will understand our language. The facial recognition in doorbells, in access control, in commercial applications, in robotics. There is so many applications for Akita that it's difficult to pick a specific application that's the ideal application.
Yeah, and what's really unique is that, we have a very dynamic sales force that we're continuing to build out and scale. It's grown dramatically over the last few months by the leadership of Chris Stevens. And what I want to emphasize beyond that is that we've also started to build out on the ecosystem and partnership side. But all of that is enabling us, as Peter's kind of highlighted, is that we have a broad spectrum of where the technology is going to fit very well in a very short amount of time. But Nandan, do you want to build on that? What's your mindset?
No, I think that's a really good starting point, right? So Akita AKD 1000 was designed to enable partners to prototype, and actually BrainChip has morphed our business into really recognizing the ability to build our engine into different system-on-chip solutions, right? And the key benefit of this is this gets combined with other compute you may have, other intelligence you may have, into solutions that fit particular markets. So the Akita technology is much more broad-based than just the AKD 1000. Having said that, it has actually helped us blaze the trail in a lot of ways. You could see automotive, in fact, some of the big announcements that we have seen are in how does a very compact AKD 1000 based solution help with in-cabin experience, more intuitive human interaction with the machine. And especially in the automotive world, where you're moving closer and closer to partially electric or fully electric vehicles, any energy drain is a challenge. Any reduction on data across the system, communication across the system that you can manage is a big benefit. You see similar situations in industrial. What we find AKD 1000 setting us up to do really well is to get closer to the sensor, bring more intelligence to the very edge, reduce the amount of computation that gets further up the network, reduce the amount of data that needs to go further up the network, protect this data going further up the network. So you end up seeing interesting solutions for any kind of human-machine interaction that is more intuitive, whether it be in automotive, whether it be in industrial, whether it be in consumer, whether it be in healthcare. In fact, some of this technology will lend itself really well in future devices that can be embedded and run on batteries for years or energy harvesting. And AKD 1000 helps us put that platform in place for people to develop those prototypes, develop those innovations, develop those models that can actually be taken to market.
Yeah, that's great. And Nandan, thank you for explaining it that way. That was you were spot on. One of the things we just announced, very exciting. A lot of people were interested in what's next from BrainChip. Where are we going? How are we getting there? What are we doing? And so we announced AKD 1500, which is basically an 8-node piece of IP, and we're validating that using our partner Global Foundries. And we've done that because what IP is like, it's like a cookie recipe. And the important thing about that cookie recipe is you want to make sure it works the same, it tastes the same in any environment that you bake it in and you build it in. And so we've partnered with Global Foundries in a 22 nanometer process. So we're making it smaller, much more efficient from a power standpoint, much more effective, but much more powerful as well. And so when you look at AKD 1500, again, we're building off the same theme of there's a lot of areas in which we can take this technology as we continue to evolve. But in specific, Peter, are there any specific areas where you think AKD 1500 is going to thrive?
Yeah, AKD 1500 is a much smaller footprint than Akita 1000. It doesn't have the CPU on board and other bits that a customer may not need. It's very suited for consumer applications and sensor applications, industrial sensor applications. So these are the main markets that I see application of Akita 1500 in.
Yeah, and just building on what Peter said, talking about consumer-based applications and industrial-based applications, for our listeners, we expect those two areas from a market standpoint to be very high volume. And to us, volume is very important. Nandan, do you want to add anything?
Yes, I think, let me start back with the philosophy that you started with, right? We have proven it out in 28 nanometer, which is where the AKD 1000 was. Now moving to 22 nanometer FDSOI, silicon on insulator process, it is going towards much more of these low leakage, low power applications, as you say. But it highlights a couple of other things. We talk about scalability. And the one word we haven't yet mentioned about Akita, it's based on neuromorphic principles. It's an event-based architecture that draws from how the brain works. And the assumption in the industry is that neuromorphic means analog because that's how our brain works. What's cool about Akita is it's designed as a fully digital architecture, and hence very portable across different foundries. And what our AKD 1500 does is show how portable it is across different process types, different process technologies. Now, the second thing AKD 1500 does is focus on what you talked about as volume markets, but really truly making it an accelerator, right? It's designed to be a processor or an accelerator. It does not need its own CPU. It can be created into a module with an MCU, or added as an accelerator for partners that want to build cards out of it. It's a great design to prove that out. But the second piece is one of our key strengths is for at-sensor intelligence, especially for feed-forward networks that fit. We don't even need a CPU. So we can actually reduce the overall BOM cost for intelligent sensors by just having this accelerator along close to a sensor. It manages its own access to models, to weights, does its own computation. So AKD 1500 is a great vehicle to demonstrate what is achievable, especially at the very edge. Now, the other thing you mentioned is that it's an 8-node smaller footprint platform versus an AKD 1000, which is a 20-node platform. One of the key benefits of the Akita architecture is the ability to run what we call multi-pass operation. And what that means is if you're constrained in footprint and you still want to learn or run larger models, we have the ability to do that on its own, completely transparent to the user, and still achieve the kinds of metrics that we need. And this is another way to demonstrate that. And actually a great way to showcase how you can start with a particular configuration that you have and future-proof for heavier applications coming down the road.
Thanks, Nandan. And one of the things I really appreciate about the way that Nandan paints the picture and communicates, he likes to leverage the word intelligence. And sometimes I say compute, but he's really right. This is about driving the intelligence and making devices, whether they be on the shop floor, in our home, in a vehicle, or in a lot of different medical devices, making them more intelligent. And that's what we're driving forward with our technology. Let's have some fun. Let's start to look at the future a little bit. And Peter, this is where we get excited because this is the stuff that you focus on a daily basis. But let's look at in the short term, we'll call that the next 3 years. So when you look at in the next 3 years, tell us what, from your crystal ball, what do you see?
Well, yes, we are actively researching new network architectures for the future. And here in Perth, our entire team here is dedicated to finding better ways of doing things. What we see for the future is that we will be expanding our market beyond what is traditionally the edge. So we will take a larger part of what's currently being done in the cloud. And I'm particularly thinking about like self-driving cars, robotics, and also the home market, home automation market. For that reason, we are studying the neurology of the upper layers of the human brain, the cortex, is where all our conscious thoughts are taking place and high-level processing happens. And we implementing those architectures within the neuromorphic core. And I just want to explain a bit more about the neuromorphic core, because purely neuromorphics has a bit of a name to it that people think they think analog, as Nandan mentioned, and that's not where we are at. We are doing everything digital. We are also wrapping that neuromorphic core in with convolutional functions, so that convolutional networks can run very efficiently on that neuromorphic core. And the neuromorphic core is extremely low power. The overlaying convolutional layer, a convolutional shell that sits on top of the neuromorphic core, enables us to interface to existing applications that are trained with deep learning, but also we have a capability of continuous learning, so that we can use the features that are in the convolutional layers, and then use the neuromorphic core to learn new objects. So that's all of those things are very exciting things for the future, and we're expanding on that. In that we're using the same type of learning within the cortical architecture, which means we make Akita smarter and smarter.
Yeah, this is where it gets fun. Whenever we're in planning sessions and I get to hear a little bit more about what Peter and team are doing in Perth, that's again another reason why I just shake my head and say, yes, we are onto something very special here. Nandan, do you want to add anything when you look 3 years out from now?
I was going to poke Peter a little bit and say, hey, we do learning today. Right.
Yes.
So AKD 1000, AKD 1500 already have the ability to do on-chip learning, one shot, few shot. And in fact, some of the videos that illustrate how actually capable that learning algorithm is, or learning capability is on today's platforms, should be quite kind of an eye-opener to what is possible when Peter gets to delivering the things he's talking about, right? So I think let me kind of step back 1 second and say, right, we're talking about extremely efficient devices at the edge that are much more intelligent, right? Now, this is a spectrum. This continues. There may be step functions in the way we improve our architecture, and you'll see lots coming out as we go along. It's not just a 3-year step function process. We're incrementally improving it. You can think of, as you say, more and more complex workloads being done on the device. So can you go to a trail cam and not be connected to the cloud and fully recognize your terrain? Can you recognize the wildlife? Can you recognize the fauna, right, and the flora? Those are kinds of things that you may be able to see with specialized applications using intelligent low power implementations of engines like Akita. Could you actually proactively monitor health, warning doctors ahead of a capability or an issue that a person has? Now, again, remember, when you're talking about healthcare, most of the signs are guidelines, right? each person is very different. So if you have devices on you that are very generic, you're not getting the full benefit that you need for a device that learns more about you and customizes itself. And once, let's say, an embedded device is installed in you, you can't do the operation every time to take it out. So the ability for that to future-proof to improvements in algorithms, but more importantly, customization that you need, is a very, very interesting scenario. We talked about the AI Labs announcement we did earlier this week. Now, according to various studies, unplanned shutdowns of production lines are $50 billion, costing $50 billion to manufacturers yearly. Can you envision the amount of productivity gain if you were solving those problems ahead of time?
Absolutely.
What innovation could be had when you keep that all possible. So I think the interesting thing you will see going forward is the ability to predict problems based on all your local data and solve them ahead of time so you can actually get the benefit of this intelligence.
Yeah, thanks, Dan, and that's great. Okay, we're going to look further out. I mean, it just so happens that 7 years from now, we'll be at 2030. Wow. Let's talk about 2030. So, Peter, when you think of 2030, you think of BrainChip and you think of BrainChip's Akita and the evolution of what we're doing for our listeners in a very short amount of time. What would you want to convey to them?
Yeah, 7 years from now would be our target for what we would call Akita 10, which is a device that doesn't just learn to recognize new objects or learn new faces or whatever, but it learns to interact with the world the same way as a human being interacts. And learning is a very interesting part of research in that it is the gateway to intelligence. Children are not born with full knowledge. They need a long time to learn. We are thinking of future artificial intelligence in the same way, in that it's born with a standard set of knowledge, but that it expands on that knowledge as it learns. So a self-driving car learns to drive better over time. Machines in this industry learn to do that task better over time. This is the holy grail of artificial intelligence. Is what we're working towards is artificial general intelligence.
So
I
was going to ask Peter. So are you predicting AGI by 2030, Peter? Do we have the singularity by then?
We will. I don't like the word singularity because humans are quite unique. We are very creative. We dream. I don't think we build machines that have the same capability by 2030. I'm not sure if we want to build machines that can envision different futures for themselves. What we want is machines that are intelligent enough to learn how to drive a car, learn how to operate a machine, learn how to make pancakes for breakfast. This is the sort of limitations that I would like to put on intelligent machines, that we don't get into like a Hollywood scenario of robots taking over the world. That's the reason why I don't like the idea of a singularity. People who look beyond the singularity, artificial superintelligence, humans are quite unique. We have 86 billion neurons in our brain. We can combine things that seem totally unrelated to come up with new solutions. We don't expect to be there by 2030, and what we will develop is safe and beneficial AI.
Yeah, thank you. And we're going to wrap this up, but I think that the theme that we at BrainChip want to build on, and what Peter just highlighted there, is learning is the gateway to intelligence, And one of the things that we do very well is we learn. And we've just started down this path. So, all right, let's have some fun. So, this is unique. Again, we're doing the fireside chat here, but for our listeners, they're used to me asking this question at the end. And Nandan, I'm going to start with you. It's a mainstay on our podcast, and we close with our get to know question, which is, if you could be one superhero, who would it be and why?
So, with due apologies to Marvel Comics, my superhero actually is my dad. Especially because, apart from being able to do anything, the work ethic to handle anything, the patience to deal with me growing up, but especially for the last 4 years, he's been dealing with his cancer, very mutilating and debilitating, but has been the epitome of positivity. And so, like everything, right? You want to emulate a superhero. That's who I would emulate.
Yeah, that's special. Peter, who would be your superhero and why?
Well, I've had a superhero for some time. I think my superhero is not Marvel or anything like it's a real person. It's Albert Einstein. For the simple reason of how he managed to think outside of the box and come up with solutions that nobody realized were there.
That's a good one. That's a real good one. So guys, I really appreciate you taking the time, and thank you. So Peter and Nandan, I want to thank you for spending time with us and providing your insight and feedback today. It's truly appreciated. For our listeners, on behalf of the BrainChip team, we want to thank all of you, as well as our customers and our future customers, our employees, our investors, our analysts, and everyone interested in learning more about AI, and most importantly about BrainChip. We truly appreciate all of your passion and support. I promise you this, our podcast series will continue, and in 2023, we'll be doing some unique things very similar to this podcast, and trying new things out. And, until our next podcast, we wish everyone to stay healthy, stay happy, and most importantly, stay out of trouble. Thank you.
Okay, thank
Thanks,
you.
guys.